And as I increase the potentiometer here, we adjust the voltage. As you can see the voltage rising. 5 volts, 6, 7, 8, 9, 10, 11. The maximum I could get was 11.97 volts DC, right? Hey guys from the channel, welcome to another video. Right, today what I'm going to bring you is a buck converter that goes from 13 volts to 47 volts for 3 amps, right? The CI or controller as you prefer to say that I'm using is the LM7526T. I'll show you in the course of the video. It's a great CI with feedback and all, but going forward you'll see how to test it in practice, right? So you left a lot of like on the boost converter. Those who didn't watch it, watch the whole video there and then you come back here, because that one is interesting as hell too, and it's the opposite of the one I'm bringing today. That boost converter, it raises the voltage, and the one I made today, it lowers the input voltage. Okay, this is great for you who have that sinusoidal inverter that you want to work with 12, 24 or 36 or 48 volts input. This one works with sinusoidal inverters with EG002 from 12 to 36, supports an input voltage of 47 volts, if I'm not mistaken, so you can turn it on to 47 and adjust the potentiometer and leave it at 12 volts to feed the eggs, like that has 3 amps of current is more than enough to power the EG002, so you will use it for several applications. Okay. You can even use it in your car, you put it in the cigarette lighter with 12, regulate to 5V and charge a cell phone. This is just a suggestion, since there is already a radio that has chargers that charge the cell phone. It was, as you can see, this inductor here is taken from an ATX source. If I'm not mistaken, I wound 27 turns here with 8.0mm wire. Here it is, I'll call it CI, LM256T. This diode here is to protect the transistor in parallel that it has inside it from bursting. So here is the input that you can enter from 3 to 47 volts or 50 volts. The output here is practically 1.2 volts up to 47, according to the component manufacturer it supports up to 3 amps, you don't need a MOSFET or additional transistor. To switch the inductor here, okay, it already has 2 transistors connected in parallel. I'll show you the component diagram, so that's it. Here we adjust the voltage. I didn't have a good result with this potentiometer here. I put it because in the schematic I put this one here, but I'm going to test it for you with another potentiometer because this one didn't look good, it doesn't regulate voltage. But in the layout and in the top silk I'll leave the schematic for you here at description for anyone to download the layout, the schematic, the top silk. I did it with this switching source inductor to show you that you can also do both the boost with it and the buck. I did it with it, but as it is an iron powder and I needed a lot more turns to be able to give more or minus 120 microhenry, as that one was a pure ferrite inductor, about 10 turns that I gave it, it quickly reached about 70, 100 microhenry. In practice I will show you the correct photos that I took of the inductimeter. Okay, so let's go to the computer. I'm going to show the block diagram, the project schema. I'll explain how it works and we'll go to the test in practice, so let's go to the video. So here we are, with the component. There is the LM2576 itself. Let's study this component here quickly. It goes from 3.3 volts, 5, 12, 15 volts. You can adjust it with resistors that already leave it there for you, which are the main tensions there, the most usual. It has an adjustment here of voltage output from 1.23 volts to 37 volts and more or less 4% of variation. The maximum output current is 3 amps. There is an internal oscillator here of 52 kHz. It also has shutdown, if I'm not mistaken, is pin 5, on off, 0.3 volts. If you have a shunt it turns off. You can do a current protection. We can try if you leave a lot like in version 2.0 with this same CI here. It all depends on the like of you there, okay? So here what I'm going to do is more or less this schematic here. I just changed the values of these capacitors here. I changed this diode here. I changed the inductance of this inductor a little. I put 120 microhenry in here. I'm going to work in the margin of 12 volts. Because I don't have a source above 12 volts, so I'm going to work with 12 volts, but I'm going to regulate it for you and you'll see that it goes up from 1 volts to 12 volts. If I inject up to 40 volts here at the input, it would also regulate 40, for sure. It is a great CI for me. Here is its block diagram. Look how much function it has here. It has a reset, a shutdown, internal oscillator. This resistor here, it has the reference of 1.2 volts for you to do there on pin 4. so as you can see it works like this. If you want a voltage of 3.3 volts, you put a fixed resistor of 1.7K over a resistor of 1K, you will have 3.3 volts. If you want 5 volts you put one of 3.1K, if you want 12 you put one of 8.840 ohms, if you want being 15 volts you put a resistor of 11K and 300 ohms, understand? So here I'm going to put a potentiometer for us to have an adjustment from 1 to 37 to 40 volts, right? Here the maximum that we can put voltage is not 45 volts on it that it will withstand, the on and off here which is minus 0.3 volts plus 0.3 volts which is pin 5, the on and off, okay? Here are some requirements that don't matter, so the video doesn't get so long. If you want to study the component further, I highly advise you, just study it in its datasheet there to get everything right in your assembly. So there it is, this is the CI that we will be using, and now guys I will be showing the diagram and the layout in Proteus, and then we come with the test in practice. So here's the schematic, right, as I don't have this one in the Proteus components list, so I preferred to draw the components to be able to show you the schematic and leave it for download there for you to download. This one is an inducer that I used, 120 microhenry. The diode I used it is not the 1N, it is the ultra-fast diode, it is the UF5404 diode, right? It is a diode for 3 amperes if I am not mistaken, 400 volts, it is quite enough for this here, so you can handle it calmly. So according to the manufacturer they recommend a diode here of 3 amps, and here a maximum current of 3 amps comes out. So here is the input capacitor, you put yours. If you are going to work with a high voltage of 37 to 40 volts, you put the filter capacitors that support this, okay? So here's a consideration. What I did and went wrong was the following. I bought a 10K potentiometer because here I didn't have where I bought it, so I did the following. I bought the 10K potentiometer and put it in series with one of 39K, to be able to add 50K, right, to be able to have the adjustment from 1 to 47 volts. But it didn't work because when this potentiometer drops to 0 then it stays 39K here, so the voltage doesn't go down anymore, right? So when it goes up to the maximum, when it goes up its resistance it gets there 49K, when it goes down to 0 it stays 39K, so it doesn't have the perfect adjustment. Like here you have the resistive divider, you have this 1K2 resistor connected to the GND, to the ground, and here you have the 50K connected to the positive, and here in the middle there is the reference to be able to come here on pin 4 of the CI, which is the feedback. So I advise you to buy one of these here, 50K direct, and get there by connecting directly to the positive. And to the output of the potentiometer here you connect 1K2 to the ground, in the middle of them in the divider here, in the resistive divider which is doing the division of plus and minus, you pull to pin 4 of the feedback. Its pin 1 is the V-in, is the positive voltage, pin 2 of this CI is the voltage that will switch this inductor, pin 3 is negative, pin 4 is the feedback that gets here in the resistive divider, right, and pin 5 is on and off. If you want to make a shunt to be able to turn it off, make a current protection module, or if you want to put a switch it is on and off. If you don't want to use it you just land and that's it. So here's the layout. This layout I made. I'll pass this one on to you and you'll do the next one. Here you'll take and put a 50K potentiometer straight, okay, and here's where you have this 39K resistor, don't put it on anymore, you take it and jump it straight from the positive will come here, go through 50K, and from here it goes up to pin 4 of the component, and here as you can see it's in the middle of the resistive divider, here it already has 1K2 which is in the negative, right? The rest will remain the same, but the only thing you are going to do is put this potentiometer here of 50K and jump here where the 39K resistor would be, so it will work perfectly. As I don't have this one here at 50K, I'll go there from an old junk radio and VU regular for you guys to see that it's working normal. That's how our board will look, more or less. As you can see, here you are going to place an inductor standing up. I didn't do it lying down to occupy as little board as possible. Here comes the jumper, you know. Here I put it now, and here you will adjust the voltage of the feedback there, right? So that's it. I don't have anything else to say. I'm not going to explain how it works because the video is going to be too long, so let's go. So guys, I've already passed the layout and top silk here. I left this part all black there to corrode much faster in the perchloride. because the perchloride will corrode only this white part, and as it is a converter that passes 3 amps of current, it's a little reinforced there, the trail of the negative. Here is top sil, it's exactly right there. You're going to fit the components, just download it, move it to the board and everything's fine there, okay? The potentiometer, here the LM7526T, the part of the diode and the inductor there. So let's go to the video that I'm going to move now to the board. So guys, as you can see, I've already separated the components that you're using, the main components. I'm ignoring the electrolytic filter capacitors, but the main one is there, the inductor, the LM2576Ci, there's the diode, there's the 10K potentiometer, the 1.2K resistor and a 39K resistor. The inductor is already there with 100 microhenry that I let go. I put 2 more turns to 111 microhenry, so let's start assembling our buck converter. I'm giving you this range, 120 microhenry, so this will be the inductance I'm going to leave, this coil here with an ATX source toroid, remembering, you take it from an ATX source, okay? I wound the wire 0.8 millimeters. The finish was like this. You can improve a lot on yours, make it more neat, right? Guys, coming back here, now it's the practical test. First it was the theory that I like to explain, well explained for you to understand what you are setting up and not generate any possible doubts. I will show you that with this potentiometer here I could not regulate with that 39K in series with a 10K potentiometer, or trim pot as you prefer to speak. So I'm already here with the 12-volt router source, and I'll put it here in the buck converter for us to see the output voltage and to show you that I can't get the tension setting right. So beauty guys, our buck converter is already energized here. I'm going to do the test for you and then charging this cell phone here for you to see. So here I'm going to show you the voltage of the converter, and this is the voltage that is there in the converter buck. It is the same voltage that is entering the source. If the source is entering 12.5, this is the drop, or the loss, or the drop that is being dissipated in heat, or the voltage that is at no load that the circuit itself consumes. So I'm going to run the potentiometer here. You'll see that I won't be able to change the voltage. Look, I'm running and the tension doesn't even move. It varies a little, it doesn't change, because regardless of whether I raise this potentiometer to 10K, it stays 49K, but when I lower it to 0 resistance, the resistor is still 39K, so I can't adjust the voltage. I turn the potentiometer and I can't adjust. He just keeps delivering what he has at the input, he delivers at the output, so I can't adjust it. So what did I do? To find this error, I imagine that in the video of this converter that I made there, I recommend you watch it. I wasn't getting it regulate the voltage right here, possibly because of this potentiometer here, but it is working perfectly. So here I'm going to take this component and I'm going to solder this one. This one is a 50K potentiometer, which I took from an old radio. If I'm not mistaken it served as volume, so I soldered 2 wires here. I'm going to solder it on the board and we are going to adjust the feedback of our converter, so here we go. So here guys, just put the 50K trim pot on yours, cancel this 39K resistor, connect it directly to the trim pot part, on the positive, which comes straight out of the inductor in the filter capacitor, with a 1.2K resistor, and send for pin 4 of the feedback. I didn't remove the resistor here, but I did the following. I placed the potentiometer right where the resistor input is. It goes in here, it leaves here and the potentiometer comes, so in the positive I put the potentiometer, and here in the part that came from the potentiometer here that was with the 1.2K resistor from the negative, I soldered another part of the potentiometer, so I mounted my resistive line on the feedback resistive divider with a 50K potentiometer, right, so I'm going to call you here at 12 volts and we'll adjust it there, so we can see the voltage that we can get to 12 volts, from 1 to 12 volts there, okay? And do some tests with it, charging a cell phone, calling this Bluetooth mode there that is 3.7 volts and so guys, after I soldered the components here, I soldered the potentiometer, I left it with 0 resistance, so look at the voltage we have there. We are entering with 1.3 volts, and as I increase the potentiometer here, we adjust the voltage. As you can see the voltage rising there, for 3 and 5 volts, 6, 7, 8, 9, and 11, the maximum I could get was 11.95 volts DC, so I'm entering 12 and I have the same 12 on output. There are few losses, 3 millivolts, so when I turn it clockwise, the voltage will drop completely until it's 1.2 volts, which is what the manufacturer leaves. So this one looks at 1.2, 1.3 volts, which is what the manufacturer stipulates, so I'll leave it here. Look at 3.7 volts to connect the Bluetooth scheme there. So I'm going to connect the negative here and the positive here, and you can see it working perfectly here, and look at the multimeter, it continues at 3.7 volts, because the feedback adjusts this. It's not like the boost converter with the CI555 understands, that gives that voltage drop and this one doesn't. It can keep stable, this will depend on the current. But as it can handle 3 amps, so that's nothing for it, right? It's working smoothly. I'll put a cooler. So this cooler here is a 12 volt cooler, 1.68 watts, 140 milliamps of current, right? I'm going to turn it on here at 5 volts and it will spin very weak. Look, when it starts to run at 2.5 volts, so I'll spin it here, we will see the rotation of the cooler increasing. Look, there was a drop, a low voltage drop of 1 volt, because I'm feeding it with a 500 milliampere router switching source, so here its stabilization must have dropped, so automatically here it also drops. Here the CI doesn't even heat up because it supports 13 amps, so it's okay. So the video doesn't get so long. I'm going to try to charge a cell phone because the cell has a very low battery, so it would need an activation. I'll put the cell phone here to charge and I'll be back with you. It's a very old cell phone and it's been idle for years. So here guys, what I'm going to do is an activation process. The cell phone was made to work at least from 3.5 to 3.7 volts. 3.7 is when it is charged and 3.0 volts is when it is very discharged. So this battery I measured with the multimeter and it is giving more or less 3 volts, so I put it there in our buck converter 5.2 volts and I will put it here in the battery. But it will not charge with 5.2 volts because there will be a drop in voltage. As it is charging, it will increasing the voltage. For the cell phone to have the strength to be able to turn on the display, and I can fit it here in its own entrance and show you that it can be charged smoothly. So the activation process is this: more with more, less with less. That's not it's to be done by anyone because there may be a risk of the battery exploding or making a mistake, so don't do it at home, for God's sake. You can see that the voltage goes up as this voltage enters the 5 volt battery. The 3.4 goes up, so I'm activating the battery. That's why the technicians charge to activate batteries, and you can activate it in your house, but taking care necessary that will work. I'm tired of activating batteries and the cell phone works normally again, you know, so when it gets to 3.6 volts, 3.7, I'm already trying to start it as if it were starting a car. I'm already trying to start the cell phone. Oh, and we already charge in the normal USB. Oh, it's already 3.7 volts. In universal chargers they do that. Practically what I'm doing, they don't have any control, they only have a display and they send 4.2 volts to the battery. It's a lower voltage, it's safer, and I'm sending 5 to be able to charge faster. They send 4.20 volts because they're doing the same thing I'm doing here. Kind of universal chargers activate the battery, they take it and send it this direct voltage. You can see that the battery is reaching 3.8, it's giving a very fast charge of low current, that the source is 12 volts, input 500 milliamps. So now I'm going to try to start the cell phone, and if it starts I put it on the USB for us to see charging. The battery gave a lukewarm. Let's see if it turns on. Look, it called. This is Mr. Inverters guys, I already deserve your like. Great tip that I taught you for you to activate the battery there if it's discharged. Great tip, deserves your like. Whoever is a cell phone technician, don't take it wrong, I know you must have an appropriate machine for this, with the right current. So this one, it was low on charge because I only activated the battery, so guys I'll put it here, the same 5.2 volts are coming out. I'm going to measure the voltage that is going to the charger there. All of the voltage that is coming in, 5.2 volts, is safe because I have a charger that is 5.13, 5.17. Hey guys, our buck converter is quietly charging, so our buck converter is charging the cell phone. I activated the battery and now I'm showing you, the heatsink is cold. If I had a digital thermometer I would show you. So guys, this was the video, remembering that after these projects, I'm going to go back to this one. I bought the CI. It's a simple project too. It seems to be complex, but the only difference is that high voltage comes in. Let's put this source to work, so I can see what will be useful here at home. Subscribe to the channel, leave your like, stay with God and see you in the next video guys.